results into autograph, we get c equals 1.4, n equals 2, so that if c equals a log of r, then r equals 10 to the 1.4, and we get this final relationship between these things. Okay. So going back to our original results, here we now know how these two things are related. Just think for a moment about how powerful that is. We've just got a set of results. From that set of results, by plotting the logarithms, we've found out exactly what the relationship is between those two variables there. So for any current, I could calculate the power. And if I rearrange that formula for any power, I could calculate the current. A very useful tool that I can get just from a set of results. Let's look at another example. And then we'll set off on this one and see if we can do a similar thing with this. And you can try it on autograph. Okay? Again, it's outlined in the textbook, so you don't need to write this down. But, so let's just have a look at it. And I will leave the results table up there for you to plot it in a second. But let's go through the logarithmic approach and try and rewrite this formula. This time, experimental values are given for the quantities x and y, and it's believed that the law is of the form y equals ab to the x. So this time, instead of the power being the x being in the base raised to some power, x is the variable. And we'll see that this is a classic example of an exponential function. It's believed that the law is of this form. So what you would do is, well, if you'd done the power function and that didn't work, you didn't get a straight line, you'd maybe try this one next. Okay. So instead of y being of the form, not having much luck with this, am I? So instead of y being of the form so instead of a power function, in other words, power or y, y equals ax to the n, instead of this, which is what we've just been looking at, ax to the n, we have y equals a b, or some constant, to the power x. And this is an exponential function. Where one of the variables x is in the exponent, hence the term exponential function. One variable x is in the exponent, the power, the index. That makes it an exponential function. And we'll see that this base value b here turns out in many naturally occurring events to be the natural number e, but we'll talk about that next time. So any function that has one of the variables in the exponent is called an exponential function, not just that one with a natural number. That's a special case. And in fact, it turns out that many have that form. So what we do is we plot now, we rearrange this formula using the laws of logarithms. We're going to use logarithms because x, one of the things we're after, is in the power. We're going to rearrange it, hopefully get a straight line, but we need to decide what to plot. So we've got, according to the question, it says it's of the form y equals ab to the x. So we start off with y equals ab to the x. Whoa. Y equals ab to the x, and then we use logarithms. So what's the first thing we do? Well, first step, log both sides. Okay, and now, next step. Yeah, which law were you going to say? Yeah, we add them, don't we? Yep, so log y equals log a plus log b to the x. Okay? Oh, to the power x.
Just you want to see all this work like that.
Yeah. Yeah. Actually, on that point, for exams, you need to see the steps, but of course we can combine the two steps for the laws of logarithms, because we now know that the x can come down and become a multiplier. So you could jump straight to, therefore, log y equals log a plus x log b, yeah. Using the laws of logarithms times log b. If I write it like we did before, the right-hand side the other way around, we can then again compare with the equation of the line. And if I now write the equation of the line underneath, y equals mx plus c, we can now see that we've got to plot not log y, not against log of x, but just against x. So we don't find the logarithm of the x values, just the y values. And we plot log of y against x. If we get a straight line, then we know it's in some sort of exponential function. And once we've found that it is an exponential function, we can then find the gradient. And that tells me the log of b. So I can then find b, because b is 10 to the power whatever that is. And I can also, by finding the y-intercept, find a. So that's what I want you to do for this set of results. So if I leave these results up, you can then go through these steps, see if you can repeat these steps, but you're going to end up plotting the log of y, not against the log of x, but against x. And hopefully this time, again, you get a straight line.